Okay, let's go ahead and get started. I think all of you can hear me. If so, just type yes in chat. Let's get us warmed up for this morning. Good. Okay. All right. Welcome back to the second week. Just a little bit of housekeeping before we jump back to lecture. As promised, at the beginning of each lecture, I will put up the schedule so you can remind yourself while you're waiting for lecture to begin where we are and where we're going. Just a reminder, the attendance sheet for this morning is editable, so please click over to the attendance sheet and sign yourself in if you haven't done so already. Okay, as all of you know, last night, 11:59 p.m., your first of the 10 deliverables was due. I realize there are probably other things you would have liked to have been doing with your Labor Day long weekend than work on the deliverables. Hopefully most of you managed to succeed and get that implemented and submitted on time. Just as a reminder, the reason why I assign the first deliverable in the very first week is to give you a sense of what you can expect in terms of the load of programming in this course. So for those of you that found deliverable 1 perhaps a little bit too challenging, just let me know. We can discuss whether this course is right for you. Okay, so now that you're done with deliverable 1, as promised, every Tuesday morning we will just talk briefly about the new deliverable, which for you is deliverable 2, which will be due this coming Monday at 11:59 p.m. So you can click through at your leisure to deliverable 2. What you're going to be doing here is replacing the drawing of the single circle at the index finger. Now you're going to be drawing all the bones in the hand using lines, and at the end of deliverable 2 you should have something that looks like this. Obviously, we are trying to draw something that is 3-dimensional, which is the orientation of the bones in the hand, in 2 dimensions. So in this particular assignment, you're going to be including a number of alterations or visual metaphors to clarify or suggest to the user that the virtual hand is also being drawn in 3D, although it's only being drawn in 2D. What are some of those visual metaphors that you can see in the way in which we're drawing the lines that suggests that we're drawing a 3-dimensional object rather than a 2-dimensional object? If you have an idea, go ahead and type it into chat. The fingers are bent, right? So the actual orientation of the bones in the virtual hand should match more or less the orientation of the bones in the physical hand. But if you look carefully at this drawing, you should see that there are a few visual metaphors here. Garrett says thinner lines for more distal bones, so bones that are further away, are drawn more thinly. Exactly, right? So something about the human visual sense that we're drawing on here, which is objects that are further away, obviously appear smaller than they actually are. So by drawing thinner lines, we're suggesting that those lines are further away. Evan mentions perspective. Actually, we're not drawing in perspective here. We could. Sage says the lines are crossed over one another, right? So if you look very carefully, you'll notice that distal bones, so bones towards the tip of the hand, are occluded in some cases by more proximal bones, so bones that are closest to us. And at this freezed frame here, you can see, for example, well, you can't quite see, but obviously for most people, when they hover their hand over the device, the fingertips are going to be pointed away from them. So from their point of view, bones that are more distal are often going to be occluded from their point of view by bones that are more proximal or closer to the hand. So you'll get some experience in Deliverable 2 of implementing some of these visual metaphors to project the illusion that the user is looking at a 3-dimensional drawing, even though obviously they're looking at a 2-dimensional drawing. Okay, I'll leave the rest to you to figure out by reading through the details. Any quick questions about Deliverable 1 or the way the deliverables are playing out before we jump back to lecture?
Can I ask about the last part of Deliverable 1?
Sure.
Yeah, I try to coordinate the coordination of X and Y to make the hand move according to moving along the device, but it seems like it moves accordingly, but it's like not all along the screen. It's just like in one section of the screen for some reason, and I don't know why that happened. I try to adjust it.
Okay. So
many times.
Yeah, so that's a good question. A lot of people had some issues with that, which is how to actually take the raw coordinates that you get back from the device and scale them to the P5 window. So remember, we're using P5, the visualization package, to draw here. The P5 window horizontally ranges between 0 and window.innerWidth, and the height scales between 0 and window.innerWidth, and the y variable ranges between 0 and window.innerHeight. So you're trying to scale from the raw coordinate ranges to this range. There's different ways to do that. If you still haven't figured out how to do that, let the TA or I know, and we can talk about it during office hours. Okay. Robert was asking, when is Deliverable 2 due? I haven't written it up here on the schedule yet, but Deliverable 2 will be due this coming Monday at 11:59 p.m. Every deliverable is due Monday night, and I assign the next deliverable the following morning, Tuesday morning. Any other questions about the deliverables? Oh. No? All good? Okay, actually, just as a reminder, one other note that came up is some people had questions about whether you need to implement the code exactly as it's described in the deliverable. If something is a little unclear, a little bit vague, you can interpret it as you wish, as long as you're able to produce the functionality that's required. As long as your image or video looks like the ones that we're looking for. Obviously, your image and video is also not going to be exactly like ours. There's no way you're going to be able to move your physical hand is exactly the same way that I moved my physical hand in the video that I just showed you. But by reading the deliverable, you should have a sense of exactly what we're looking for. So, for example, the last question that was just asked about the fact that the circle was restricted to only one part of their window. That's clearly not what we were looking for. It should be clear by the time you get to the end of Deliverable 1 that we want you to be able to move the circle across the entire range of the P5 window. Okay, hopefully that clarifies things. If you have questions about Deliverable 2 as they crop up, please let the TA and I know, and we will try and help you with that. Any other questions? No, all good. Okay, so let's get back to lecture. We made it through part of the second slide deck, the basics of interaction. So we'll jump back to that in a moment. Can I just ask that everyone mute their microphones? I think someone has their microphone on. I can hear a little bit of background noise. Thank you. Okay, we'll finish off our discussion about the basics of interaction. What is HCI? What are the boundaries of HCI? And then we'll move on today to our third lecture on Pact Analysis, which stands for people performing activities inside of a context and designing technology to support those people performing those activities in those contexts. Okay, so back to, we finished last time by looking at this slide here, which is meant to communicate how broad the study of HCI is. We're going to draw on a lot of different disciplines as we go along. We're going to spend some time talking about sociology, psychology, ergonomics, anthropology, We'll dive into various forms of technology, different branches of engineering, if we're looking at physical devices. And starting probably on Thursday, we'll start in earnest in our discussion of design as it relates to HCI. A lot of other disciplines like engineering and the graphic arts also have an emphasis on design, and there are some best practices, some design best practices from those related fields that we will draw on in our discussion about HCI. We also need to think carefully not just about people, but also what they're doing and inside what context. So we'll look at different kinds of social groups, large-scale corporations, universities. These are known as soft systems. So there are explicit rules about how obviously a university runs, but there are also unspoken social norms that tend to grow around institutions of large numbers of people. As just one example of a social norm at a university, if we were meeting in person, usually after a while students tend to come in and sit in the same seat, although obviously there's no explicit rule in a lecture hall that you have to sit in the same seat every time. It just is sort of a social norm. It tends to be how people do things. Obviously, we're doing a lot of remote instruction these days, and there are social norms that are already growing up around remote university instruction, even though this soft system, a remote classroom, is only about a semester old for most of us. What are some of the social norms that you've already noticed developing when you attend a remote lecture? Everybody mutes themselves, exactly. Now, obviously, I just asked you to do so, so there's a little bit of feedback from the top, so to speak, about that. What are some of the other social norms? Having the camera off, exactly. I've requested some of you to turn your cameras on, but clearly you prefer not to, and that just is a social norm that we will all have to adapt to. Okay. I've also offered for you to ask questions using your microphone or in chat. Seems most people for the moment are preferring chat, so there you go. There's a social norm that it's at least is developing around this class. I don't know what social norms are developing around your other remote classes. Yep, raising a hand if you have a question. That's one that has carried over from physical classes. Okay, keep listening. Yes, here's hoping. Okay, so hopefully you get the idea, again, that HCI draws on a lot of different disciplines. We're going to try not to reinvent the wheel. We're going to look at best practices in other disciplines about how to design things to help people carry out whatever it is they want to carry out. Okay, so as I just mentioned, HCI kind of has two legs. One leg is the theoretical base of HCI and is planted in cognitive psychology. We need to think carefully about how people think and what expectations they bring to an interaction with their physical environment, other people, and then technology. The other leg of HCI is planted in software engineering. As I've mentioned before, software engineering is kind of the sister course, the sister class to this one. And in software engineering, like you'll see here, there's a lot of emphasis on design. There's lots of ways you could go about designing software or designing an educational ASL game around Leap Motion. There are probably better ways to carry out that design than others, and that's what we're going to spend a lot of time looking at, design best practices. We're going to focus not so much on the internals of code in this course. We're going to focus much more on the point at which people and the technology come into contact with one another, the interface itself. At that point of contact, there are a lot of things that are going on. Some of them are obvious and some of them are less obvious. And one of the things I hope you learn in this course is to identify, before the technology has even been created, what some of those unspoken or non-obvious kinds of interactions are going to be, and to take those subtleties into account when you sit down to go about designing the interface. So as just we're going to just start to unpack this idea of what's going on at the interface. At sort of a very high level view, there are three types of interactions we can talk about. Physical interaction, if we're talking about a keyboard and mouse, the user is pushing buttons, moving the mouse. If we're talking about a smartphone, the user is entering or leaving wired spaces. If we have a joystick that might actually have a motor inside it, the joystick may actually provide resistance to the user's attempt to move the joystick. Physical interactions are pretty obvious, right? If we watch someone at a keyboard, you can sort of see what kind of interactions are going on. Then there are perceptual interactions. These are interactions between the user and the technology that are at a distance. The user isn't necessarily touching the device or in contact with the device. But often the meat or the bulk of the interaction that's being supported by the technology is occurring in this perceptual set. So the technology is displaying something that the users can see, they're making noises that we can hear, or vice versa. We are making sounds that the microphone on the device is picking up. Much less obvious are the forms of conceptual interaction that are going on between the user and the technology. As the user physically and perceptually interacts with the technology, they are starting to form expectations about how the technology will respond when the user does something. So most users, whether they're aware of it or not, are thinking about what the technology is doing and also what it should be doing. So most users are trying to accomplish some activity with a given technology. Does the user's conception of what's going on or what the technology is supposed to be doing, does that line up with what the technology is actually doing? Often those are not aligned very well. So for example, even with the Leap Motion device, you might not always be aware of whether the device is actually sensing your hand over the device. The Leap Motion device has some functionality built into it to try and advertise back to you about whether it is on and sensing your hand or not. What are some examples of visual feedback or feedback, any kind of feedback, either from the Leap Motion device or other kinds of technologies? How did technologies advertise what they're doing to help support users build up an understanding of what the technology is doing? Prasida is asking about the recording. I am recording this lecture. I'm just recording it outside of Teams. So when you type the letter, it appears on screen, right? So that's an obvious indicator that the keyboard has successfully captured a keystroke. The cursor, absolutely. So it shows you that the cursor shows you that the mouse is on and responding. Vibration. So Nana, under what example? What's the example of vibration? What technologies use vibration to tell you what they're doing? Julian mentions a change in brightness. So you might have a light sensor on a device that is intelligently tuning the brightness. Haptic feedback on a touch screen, exactly. So when you touch a touch screen, how do you know whether it captured the fact that you touched the screen? Often you'll get a very slight vibration, which is the device telling you, I got it, I know you touched the screen. Yep, that's a great example. Okay, you can think about that at your leisure. Just to re-emphasize this point, we're going to look at all these different types of interaction, but we're going to be focusing on some of the more subtle ones that are not always obvious and try and support those conceptual interactions. So let's look at an example. This is the Nintendo Wii Remote, which is a sort of a game controller developed by Nintendo. There's the remote itself that the user holds in their hand, and they point the remote at a sensor bar which is sitting just above or below the TV screen. Inside this remote, there is a camera which can see the two clusters of sensors at either end of the sensor bar. And there is also an accelerometer that is inside this device, which senses motion of the device or rotation of the device. How does the device know its relative position to the sensor bar? You can see that it needs to know 3 coordinates, x, y, and z. How does it know its relative position relative to the sensor bar? So the accelerometer inside the device tells the device about motion, but it doesn't tell it anything about its actual position. So the infrared sensors, yeah, exactly. So it's picking up the light sources here, but how does it use the light coming from these 2 clusters of lights on the sensor bar? How do the cameras on the remote tell it where it is relative to the sensor bar? It could be the time it takes for the light to reach the sensor bar, somewhat like the Leap Motion device, but in this case it's just normal light. So try to put yourself in the shoes of the device itself. It's looking at these 2 groups of lights. So Willem's got the right idea here, triangulation, right? So X is pretty easy. If the device sees the 2 clusters to its right, then the device knows it's to the left of the sensor bar. If the device sees the 2 groups of light in its left visual field, then it's to the right of the bar. If it sees the lights in its lower field of view, then it's above the sensor bar, and vice versa. The Y direction, as you can see here, is based on triangulation. So if the device is close to the sensor bar, those 2 groups of lights will appear very far apart. And if the device is very far from the sensor bar, those 2 groups of light will look very close together, based on the phenomenon of parallax, as Joseph says here. Okay, so we have a device now which knows it knows its position, its 3-dimensional position in space, at least relative to the sensor bar, and based on the accelerometer, it knows the rate at which it's moving left and right, up and down, forward and back. That's linear acceleration, and it also knows how quickly or how slowly it's rolling, pitching, or yawing, which are the 3 rotation variables. So it knows its linear acceleration and it knows its rotational acceleration. How could we create a game that exploits the physical interaction, the fact that the user is holding a device and moving it in space? Perceptual interaction, which is the device is interacting with the sensor bar at a distance. The user is maybe observing the remote itself or observing the screen and the sensor bar. How do we take all those and pull together the physical interaction and the perceptual interaction to create a satisfying conceptual interaction for the user? They feel that they're inside the game. Okay. Let's start with perceptual interaction. Let's imagine that we're creating an archery game. So the user is using the remote to simulate a bow and arrow. They're clicking or doing something on the bar on the remote to release the arrow, and the orientation of the remote, which the remote is able to sense, indicates the angle at which the arrow is going to start moving. There's a couple of other details. So there's a small speaker on the remote itself, and obviously speakers on the TV screen. So let's think about sound for a moment. We've talked a little bit about visual metaphors in this course. This is the first audio metaphor we're going to see. Imagine that the moment that the user clicks the bar and releases the arrow, they hear the sound of an arrow being released from the remote. A short time later, assuming that they aimed the virtual arrow at the target correctly, they hear the thud of the arrow hitting the target from the speakers on the TV. Okay, what is the audio metaphor that we're using here? Or what is the audio metaphor that we're creating here? if you have any experience with actually firing a bow and arrow, we're exploiting some aspect of that we're exploiting. So as Joseph says, we're exploiting the fact that the arrow moved. Yeah, can we be a little bit more specific than that? What is it about the physical process of firing, using a bow and arrow that we're exploiting in this audio metaphor here? The distance between the person and the target, right? Exactly. Okay, so let's now move on to conceptual interaction. Let's imagine someone has never played this game before. They pick up the remote, they see the target on the screen, they shoot an arrow, they miss the target, they move the remote a little bit, they click again, they hit the target. Let's imagine that the user then moves a few steps away from the TV screen and fires an arrow again. What do they expect to see and hear in that case, if this visual and auditory metaphor line up? They've never fired an arrow from this far away from the TV screen before. What is their expectation? As Jillian says, they expect that there should be a greater pause between the two sounds from the remote and the TV. They may or may not be aware that they have that expectation, but if that pause is the same or shorter, that's going to create a frustrating or confusing experience for the user. Even if you were to ask them after the fact, they may not be able to articulate to you what it was about the interaction with this particular video game that was frustrating or confusing. So it took us here just a few seconds to think carefully about the physical interaction, the perceptual interaction, and how those set up a conceptual interaction or an expectation from the point of view of the user. Sarah mentions the second sound should actually be a little quieter. That's a great example. Yep, that might be an additional detail we could build in. So that's what we're looking to build up an understanding for in HCI, as to how to pull out or expose these unwritten or non-obvious expectations we bring from a physical activity, in this case archery, that we bring to bear when we try and recreate that activity in a virtual setting. Okay, so obviously in order to do that, we need to think very carefully about people. How does our visual sense work? How does our auditory sense work? Where do these expectations come from? And how do these expectations and predictions differ across people? In HCI, when we go about designing HCI technology, we're putting more of an emphasis on people's needs, their abilities and skills, rather than putting emphasis on what the technology can do or needs. So obviously this means putting people first rather than putting technology first, but that's kind of a overly vague statement. So can we make this a little bit more concrete? It means a lot of different things in HCI. First thing to think about is obviously what do people actually want to do? If they have to use a technology like Microsoft Teams, for example, what are they using it for? How do we design the technology to make sure that we're supporting what people actually want to do? Most of the killer apps throughout the history of computers are apps that are designed in such a way to connect people to people, and often to connect them in new ways, create new kinds of social interactions that were difficult or impossible before without that technology. More specifically, if we have a group of people that are trying to connect with one another to actually carry out a job together, how do we create technology to maximize synergy? So if we have a bunch of people that are building or making something and each person is working on a different part, how do we make sure that they're able to communicate and synergize their efforts rather than work against one another? There's a lot of HCI dedicated to that, which we'll come back to in a moment. A lot of HCI tries to involve people in the design process itself. So instead of a user passively sitting back and using a technology that doesn't change, a lot of modern HCI interfaces actually allow the users to not just reconfigure or configure the settings of the technology, but actually actually change the technology itself. And we'll talk about that again in a moment. Finally, and again, we'll spend a lot of time talking about that in this course, is to design for diversity. Different people have different needs, abilities, and skills. How do we create a technology that is useful, allows people to do what they want to do, and allows lots of different kinds of people to do what they want to do? Okay, let's start with number one here. What are some technologies you can think of that are very well designed? They obviously were built to support what people want to do, and the actual horsepower of the technology is sort of hidden in the background. It's not that important. Can you think of some examples of either software or hardware that's good at that? Or alternatively, examples of software or hardware that's particularly bad at that? Okay, a light switch, that's a great example. It's pretty simple, pretty straightforward. What are some more software examples or software-hardware combinations that very clearly support exactly what the user wants to do and nothing more? Microsoft Office, okay, so a number of applications which are designed for writing, spreadsheets, for text, numbers, drawing, and so on. The computer mouse, yep, exactly. Remote control for TV, that's a great example. There's some remotes out there that have very few buttons on them, and then there are remotes that are the opposite. They have a gazillion buttons on them. Joseph mentions Google. This is the most common example when I asked this question. At least back when Google got started, all you had was a blank white page, and in the middle was this bar, and you could click in this bar and type in something and click one of two buttons and get back most of the time what you were looking for. If you go back and look at the 90s and the competing search technologies at the time, they were the opposite. They had a whole bunch of stuff on the screen, and it was often difficult to figure out where you had to click or type to search for something. Okay. What about examples of technology or software packages or apps that created new ways for people to interact? Most modern HCI technologies or interfaces are designed for social reasons, allowing people to connect together in new ways. Facebook, one of the first social networks, of course. Skype, so video conferencing. Instagram, all the social networking applications. Chat rooms, yeah, exactly. Okay, email, right, an older example, the internet itself. A lot of these technologies now allow us to interact with other people in ways that would be basically impossible without those technologies. What are some examples of technologies and their interfaces that allow people to more easily work together? So let's assume for the moment it's not Facebook, it's not just people hanging out together, they want to actually do something together. Google Docs is a good example. GitHub, obviously, which you're working with in this class. Let's focus on GitHub for a moment. Some of you are just learning GitHub at the moment. Lots of other great examples in chat here. What are some aspects of GitHub that help you work together? What are some of the challenges in working together in a large group that are solved or made easier by GitHub? So Robert mentions branches. What is it about branches that help people work better together? In order to answer this question, you need to think carefully about the social activity of trying to build or make something together. What are some of the things that can go wrong when you have 2 or 5 or 10 or 100 or 1,000 people collaboratively trying to create something together? So Robert says people can work on a part of the program and not mess up the master. Exactly, right? So the more and more people that are collaborating on something, the greater and greater danger that a change made by someone over here is going to break a change or something that was recently created by someone over here. So branches is one mechanism in GitHub that adds some modularity. It allows someone to work on some version of the of the artifact being constructed, and then explicitly issue a merge request. So the user can then explicitly signal to the rest of the group they've made a change, and the group can collectively decide whether to accept the merge or the pull request, right? So making something explicit. If you have a lot of people working on something together and someone is doing something over here that is not quote unquote seen or not visible to someone over here, that's when the danger of antagonism shows up, right? Somebody makes something over here that breaks something that someone is doing over here. So there are a lot of visual metaphors that are built into a merge request that help visualize or isolate or make clear what's been changed. What are some of those visual features built into GitHub that make that clear? I've made a change and I'm requesting that the group incorporate it. How does the group see or quickly understand what changes I've made and what repercussions those changes might have? So commit text. So often I read the message from the user. They say, okay, I've made changes to X, Y, and Z. I could trust the user that they've only changed X, Y, and Z. Assuming I want to go a little bit further than that, as David mentions, I can also look at a difference list. So I can bring up the original code before the user made their change, and it will then highlight just the things that have been changed, right? So I think it's plus in green for things that have been added and negative and red for things that have been removed. So it makes it much easier for the group to identify exactly what has been changed, right? There's a big challenge there, especially when you have more and more people and a growing code base, to identify, and this is the activities, to identify what's been changed and what repercussions those changes might have. So there's a lot of work that goes into collaborative software development, like in GitHub, to help users with that particular activity. Okay, let's move on to number 4 here. What are some technologies that involve people in the design process that have basically lowered the bar of entry and made it easier and easier for people to make changes to the technology itself? Open source projects like Blender, of course. So open software in general. If you're a coder and you know how to alter code, you can get in there and change the code. How about involving users in the design process that aren't coders? What are some interfaces or things that have been developed to allow users to alter the technology without having to write code? So websites, right? HTML. Because HTML is a form of code. If you look at website design over the years, obviously website design sites like Squarespace make it easier and easier for people to create websites, for the obvious observation that a large number of people want to create websites and the vast majority of them know nothing about coding. Khan mentions Wikipedia, right? Wikipedia has a lot of interesting interface features to it that make it easier for people to make changes. And now the modern version of Wikipedia also to track where changes have been made, like in GitHub. Yep, so WYSIWYG itself is an HCI innovation from the 80s that allowed people to make changes to technology without necessarily having to write code. Okay, blogs, yeah, great example. Great examples here. What are some examples of technologies that are designed well to support the diversity that we find in human populations, either to support physical diversity, cognitive diversity, cultural diversity? Can you think of some examples of where that's done well, or alternatively, some technologies that do not support diversity well? Web browsers, how do web browsers support a diverse human population? So So Sarah mentions the most recent and obvious example of where this is done poorly with face recognition software. We will definitely spend some time talking about that later in the course. So you can change languages relatively easy in a website. What else about browsers make things support diversity? What are some aspects of human diversity that are supported by websites? Closed captioning, so for example in YouTube, absolutely. So to support those that are hard of hearing, it's a good example. Password managers, maybe. I think all of us struggle equally with passwords. Google's auto-translate, yeah, that's a good example. Enlarging texts in web browsers. So that was my example here. Early on, at least if you had a mouse, the mouse wheel, or there was usually a pretty obvious way to change font size for those that are visually impaired. Humans are primarily visual creatures. So for most HCI designers, the first thing they think about once they start thinking about diversity is the fact that people have better or less visual acuity. So we often think about visual diversity first, but as already mentioned, there's a lot of diversity in auditory acuity as well, or the hard of hearing. So again, here just some examples of my own. We mentioned Google, keep it simple. Just project to the screen or project to the speakers just what people need to do what they need to do and nothing else. We talked about GitHub already. We talked about Wikipedia. I think lots of examples here. Yeah, great examples here in chat. Exactly. Okay, so putting people first is kind of an obvious, vague thing to say, but as you start to unpack that, you'll notice that there are a lot of examples out there where the designers clearly thought very carefully and very deeply about what it means to put people first and how to design technology to support that. Okay, that concludes lecture number 2. So we're going to start in on lecture 3 now, which is how do we actually go about designing, putting people first. Okay, this is often known in HCI. This is often known in HCI as Pact Analysis. So people conducting activities in a context using technology. And on purpose, technology is listed last in the sentence, and on purpose, people are mentioned first. So in Pact Analysis, we're going to think very carefully about who is going to be using the technology, what are they going to be using it for, and under what situations are they going to be carrying out those activities and by whom. Once we understand P, A, and C better, only then should we start to think about a technology to support all three. Okay, so what I just described, putting P, A, and C first, and then T, is a design approach. It's a design philosophy. That's how we're going to go about creating, or one way to go about creating good interactive systems. So again, we want to think carefully about people. First thing we want to think about is who will use it and who will be affected by it. So we're going to think about the users, but also the stakeholders. Stakeholders are people that are not directly using the technology, but are indirectly being affected for it. Most of us are spending most of our days these days on Microsoft Teams or Zoom meetings. Who are some people that are being affected by the fact that most meetings are now being held remotely rather than in person? So somebody who's not necessarily on a Zoom call or a Teams call, but is being affected by it. People without access to broadband internet, right? So there was an implicit assumption at the university that all students had exactly the same amount of broadband because they were physically on campus and using campus internet. That assumption, which supported a lot of what went on, a lot of the activities that go on at the university, that assumption has now gone away, and we are having to redesign or adapt instruction and instruction technologies to support that. As David mentions, a shockingly high percent of the US is without broadband. As Joseph mentions, participants in a Zoom call, family members are being affected. So I don't know, you've probably seen lots of people in the background when you're in a video conference on Zoom. Often it's young children because they're off school. So there are particular groups of people that are falling into the stakeholder category. Yep, students in different time zones. That's a good example of context, something we need to keep in mind. So the issue about broadband and multiple time zones are examples of thinking carefully about context. Okay, so we're trying to keep all these things in mind. Who is using the technology? Who is unwittingly or indirectly being affected by it? What are those people trying to do, and under what circumstances? Okay, so just to think about this a little more carefully, let's take 3 hypothetical examples here. In each of these examples, I mentioned something about people and activities. So in the first example, the people are teenagers. The activity they're carrying out is sending texts to friends. People flying drones together, and a person working in very close physical proximity to a robot in an assembly plant. I've had to mention some technology in these examples, like robot, drones, and I guess this implies a texting app. But I've tried to leave technology out of this for the moment. I want you to just take a minute or two, think about these 3 examples, and start to think about not just the technology to support them, but what is it about these people, these activities, and these contexts? How do they affect your thinking about the technology? If you're going to design a technology, you're going to design some software for the robots, design some software for the drones, maybe alter a texting app based on what's written here. How does P, A, and C affect your thinking about the design of T for these examples? I'll give you a minute to think about it. As you are, if you have an idea, go ahead and type it into chat. How does it influence your thinking about how you design technology for these examples? Okay, I think maybe the third one is maybe the most obvious one. As you start to think about software you might write for this robot, hopefully one of the first things you're thinking about is safety, right? How are you going to design this robot plus software technology to be safe? I'm now going to flip to the next slide, and the next slide I'm going to make a change to the context for each of these 3 examples. And I want you to think about, when you read these altered contexts, how that alters your thinking about the technology. Okay, let's think about an app that supports teenagers sending texts to friends while driving, or perhaps the opposite of supporting. Imagine people want to fly drones together during a large-scale protest march. How does that alter your thinking about creating software for those drones, for that activity? What if we have someone who is hard of hearing or deaf that is working in close physical proximity to a robot in an assembly plant? How does that alter your thinking about the design of the technology? If you have an idea, go ahead and type it into chat. Or go ahead and unmute yourself if you want to describe it verbally.
Accelerometer for the texting while driving.
Okay. Sorry, who's speaking? Is that Robert?
Yes.
Yes. So Robert, can you elaborate on that? Why an accelerometer? Why does that matter? Why did you think of an accelerometer?
If you're able to tell how fast someone's moving, if they're going above the like walking or running pace,
Okay.
like when you're in a car,
Yep.
to limit texting, or using GPS location if accelerometer isn't working.
So let's continue this example here together. So if the accelerometer detects that the phone is moving above some velocity, it would turn off the texting app. Is that your idea? Is that the idea?
Yeah, that or stop them from typing or looking at text.
Okay. So let's think about that particular example for a moment. In a lot of design, there are secondary effects. So let's assume we did build that in, and let's assume that the teenagers were willing to use an app that was sensitive to whether they're in a car or not, which is another issue. What happens if it's a teenager who's a passenger in a car? Their accelerometer.
Now.
Yep.
They have like a button. I'd ask you if you're a passenger.
Absolutely. So those technologies assume that the user is a willing participant. They're going to, out of the goodness of their heart, indicate whether they're driving or not, which is potentially a good solution. Can we indirectly infer whether someone is attempting to text and drive at the same time? How might we do it other than falling back on the fact that someone is going to agree to touch a button? So the accelerometer is a good start, but it's probably not sufficient because it will also turn off the app for those that are passengers in a vehicle rather than actively driving.
Have something that requires two hands.
Something that requires two hands, that's a good example. Okay, so a texting app that requires two hands. Let's hope the teenager doesn't take both hands off the wheel. How would you combine sensory information coming from a smartphone to detect whether someone is holding a phone while they're the one who is driving a car? Could you? So Willem mentions detect distracted typing patterns. That's a good example. There's probably no one solution here. We might bring together a constellation of features to try and increase our probability in the guess that someone is driving.
If they're staring at the screen.
If they're staring at the screen, okay, so assuming we could turn on the camera, we might be able to see their face, and we might infer something about their gaze direction. That's a good example, yeah.
What about having a sensor that detects the people at the seat of the driver while the car is moving?
Exactly.
And it makes that the phone is not working.
There's a great example. I think Philip mentioned this as well. So we could, for example, we could build in relatively cheaply a sensor to car seats, and those sensors might speak wirelessly with a smartphone that is within a close enough distance. So we might use that information, combine it with the distracted typing, inference of gaze direction. This all assumes, of course, that someone is holding the phone while driving. If they're driving and their phone is in a harness or hooked up to the car itself, it's a little bit trickier. So you can see that we are now talking not just about software. We're trying to think very carefully about the physical context of driving. So if someone is attempting to text while driving, hopefully their eyes are saccading or moving and pointing out of the front windshield often. There's something about physical weight in the seat, something about proximity of the phone to the driver's seat in the car. And we might need to do some machine learning. We might have a lot of data coming from these different sensors in the phone, in the car seat, maybe in the wheel itself, at the steering wheel itself, to try and infer, is someone actually driving while texting and either forgot or neglected to press a button saying, yes, I'm driving, please turn off text. Okay, let's move on to the second example. Let's think about a drone being controlled by various by software in this particular context. How does that alter your thinking about the software that's controlling the drone? Desire for anonymity, exactly. So whoever is using the drone software, perhaps they would require anonymity. Other ideas? So desire for anonymity from whom? The person who's flying the drone? Okay, for the pilot. Let's think carefully about the P in this particular activity and context, or pilots. So we have people flying drones. So the protesters, maybe anonymity for the protesters themselves. So in this particular activity, under this context, there is a very small minority of users, the people that are actually flying the drone, and a very large majority of stakeholders, people that are being affected potentially by the technology but have no direct control over that technology. So obviously safety matters. As Joseph mentioned, most flight guidelines do not allow flying over groups of people. So there's questions of privacy or anonymity here, safety. There are also a lot of other subtleties that should be suggested to you by the fact of this particular context. What are some of the other social subtleties that exist in a large-scale protest march that we may want to be thinking about if we are writing drone software for this particular application? Anonymity is one, maybe kind of obvious. Safety is another one, kind of obvious. What are some social aspects of this context that are less obvious? Clearly, this is a pretty vaguely defined set of people, activities, and contexts. If I asked you to start writing software for a drone to do this, you might have additional questions for me about the details of these people, activities, and context. What are some of those details you might ask for from me? Okay, so sensing very large buildings and obstacles. So where exactly is this protest going on? Is this going on in a very open space, or is this going on in a downtown core where there are very narrow corridors? So there's a lot of physical context that's implied by this. As Willem mentioned, you might ask me, who are the people we're talking about here? Are these drones being piloted by the protesters? Are they being piloted by the police? What is the purpose of flying these drones? What are the people trying to get the drones to do during this protest march, right? So now we're moving from physical context like large buildings into social context like anonymity and safety, into subtle social dimensions that might have a cultural or political bent as well, and may or may not influence how you think about designing that technology. Okay, again, as HCI designers, we're trying to elicit or pull out some of those unspoken aspects of P and A and C that are going to matter when you sit down to design T. Let's move on to the last one. If you're writing software for a robot that is going to work in close physical proximity to someone who is deaf, how does that influence your thinking about the design of that software? Again, there may be some aspects of this kind of interaction that are obvious and some that are less obvious. Okay, Ethan mentions tactile cues for proximity of robot, maybe vibration. Okay, so maybe the robot is able to vibrate or give some tactile cue to the human collaborator. That's a good start. That has an assumption, though, of course, which is that the tactile cue is only going to work if the robot is in physical contact with the human collaborator, or the human and robot are collectively holding on to the same object. Joseph mentions a dead man's switch, right, or the big red button. There should be a quick and obvious and easy way for someone to halt the operation of the robot. Perhaps a flashing light when the robot is moving. Okay, that could help. What else? Requiring human input to initiate a robot process. So who's in charge in this interaction, right? Is one person here in charge and the other person is following along, or vice versa? Or are they equal partners in whatever it is they're trying to do on the assembly line here? It's obviously not mentioned in my very vague statement here. If you were the HCI designer, you would probably come back and ask me those kinds of questions. Let's think very carefully again. Wearable computer to control and monitor the machine. Okay, that's good. However, think carefully about the person here. We have someone who's working on the assembly line. We have them working in close proximity to a robot that is now flashing light whenever it moves. We're also requiring the person to provide input to get the user to get the robot to do something. And the user is also now having to wear something to control and monitor the machine. Are we thinking carefully enough about the person and the context here? What is some context here that is being ignored so far? The type of manufacturing, possibly. What it is that they're making, yeah, possibly that matters. The person is now wearing something. They're required to initiate processes. There's a flashing light coming from next to them. What are we ignoring about the person here? Put yourself in the shoes of this human worker on the assembly line. All right, if this was you and they had to work with this robot you're designing, are they on board for all of the stuff that's going on? Is it distracting? So we're going to spend quite a bit of time in this course talking about acceptability. You may have a technology that works perfectly fine. There's no bugs. It does exactly the right thing every time. It's perfect from the point of view of the technology, but not perfect from the point of view of the user. It is unacceptable to them for various reasons. Okay, so as David mentions, the robot should track where the person is and refuse to execute dangerous tasks. So now we're putting the onus, or we're putting some functionality on the robot rather than putting it on the user. Can we offload certain tasks from the user onto the robot? Think carefully about some of the unspoken contexts here. Typically, in an assembly plant, we are dealing with people that are at the low end of the socioeconomic ladder. They are potentially working very long hours for low wages. Do we want to saddle them with additional tasks which may be physically difficult for them to carry out because they're already tired from a long workday on the assembly line? So as David continues to write here, requiring the person to do too many activities will result in accidents because of distraction or fatigue. One of the most important unspoken aspects of physical context or social context or human context in this particular situation is fatigue. What are some other ways in which we can think carefully about this interaction and take some of the load of responsibility off of the human and onto the robot, keeping in mind that the human collaborator here is deaf? So we can get the robot to track where the person is, but that may not be sufficient. It's not just exactly where the person is. What else matters? You can see in this little picture here, the human is holding an object and maybe the robot is reaching for that object as well. Remember our recent discussion about synergies of collaborative work. Here's an example of collaborative work. We have a human and robot trying to do something together. There's obviously safety things, but how do we get these two agents to work well together? So we would like the robot, as David mentions here, to know not just where the person is, but what the person can see and where they are moving. So the robot here actually has a lot of work to do. It has to be able to see perhaps the robot's arms and hands and body position and infer from that what the human is going to do next. They need to also understand what the person can see, and in order to do that, the robot is going to have to see not just the person's head, but also their eyes and where they are looking. Like again, the example of texting while driving. So that is a non-trivial thing to do. We're going to there's some non-trivial machine learning that might require the robot to see the person, infer where they're looking, and understand from that information, predict what the human is going to do next. And all of that is coming from the fact that we can't rely on the fact that the person can hear things. Okay, here's just a fun example. This was an old tweet that came across my feed. This was an example of someone who was using a technology, in this case a robot mower, to mow the lawn. But in this case, whatever the manufacturer of this robot mower did not take into account, which is, what about users that have both a robot lawnmower and a puppy? Puppies leave packages in the garden or on the lawn. Poor Morris the mower didn't realize that they were there. Okay, I'll leave that for you to think about. Okay, so we'll get back to Pact in a moment, but let's take a pause and look at another kind of feedback loop that exists, so that we need to think about when we're designing HCI technology. The first feedback loop we saw last time was between an individual user and their environment, or between an individual user and a piece of technology. The technology then project something back to the user. If we take a few steps back and think about large numbers of people carrying out related activities in a given context, and a constellation of technologies, not just one smartphone or one drone, but a whole bunch of technologies meant to support that group of people, we get a much larger and slower feedback loop, which is, we analyze people, activities, and context, and we distill that down into a set of requirements. So going back to our example here of the co-robot, the collaborative robot, we might write some prerequisites. This robot should never move its arm close to the person unless the robot is sure that the person is looking at the robot's hand, or the robot's hand is in the user's field of view. That would be a prerequisite that we might write down, and any software for that robot is going to have to implement that requirement. Once we have a set of requirements, we can sit down and design a technology and prototype it with alpha testers, beta testers, a growing group of people carrying out this actual activity. If they accept and like the technology and start using it, it becomes increasingly deployed out into the world. And that technology then, being used by large numbers of people, creates new opportunities for new kinds of technologies. So technologies often create ecological niches that can be filled by further technologies. What are some examples of technologies you can think of that, once they were adopted by a large group of people, created niches that were then filled by other types of technology? So Robert says virtual reality was wired, and then people made wireless adapters. So it's an okay example, but that's basically an improvement in an existing technology, making a technology maybe more acceptable because there's less wires around. But we're looking for two different technologies where the second technology wouldn't work or wouldn't be accepted by people unless the first technology existed. So smartphones had to exist before apps could exist. The internet, there's a great example, right? So online shopping obviously didn't exist unless there was an online. So the internet is probably the most obvious example of an enabling technology. The internet itself is useful, but it's most useful because it supports or gives a leg up to a bunch of other kinds of technologies. Can you think about any other technology pairs where one paved the way for the other? Okay, so once computers started to be used in large numbers, as Evan mentioned, that required computer management, and a lot of software packages were created to support management, basically, right? You use those, there's MyUVM is an example of that. So David gives a good example, pre-computer example. So the technology of cars and mass transit then created opportunities for other technologies like larger cities and all the technologies that come along with that. Let's come back to our example of the collaborative robot working alongside a human being. Let's assume that we started to perfect that technology and it made sense for people to work in close physical proximity to a robot on an assembly plant. Let's imagine that became more and more common. It's not common quite yet. It exists in Amazon warehouses, but not many other places. Once you have people and robots working in close physical proximity, what other human activities might then become possible? Human activities, social interactions that would have been impossible before you had co-robots, robots that can collaborate in close physical proximity to humans. Let's say co-robots exist now. What new kinds of technologies might you dream up for that? Any ideas? A robot that drives your car for you? Okay, yep, sure, that might work. So maybe the robot is sitting in the driver's seat and we're sitting in the passenger seat, and maybe you can reach over and grab the wheel if something goes wrong. With autonomous cars, that's not the direction we're going in at the moment, but who knows? So we have a machine and a person that can work very closely and safely right next to one another. Cooking, that's a good example. I like that one. Okay, we've only got 3 minutes left, so I'll leave that for you to think on. Okay, so what we're going to do now, and we'll continue on Thursday, is we're going to unpack P and A and C. As everything in this course, it's obvious sort of when you state it up front, like for example, people differ in different ways, but what exactly do we mean by that? Again, starting with some of the most obvious differences between people are physical differences. People differ in their ability to use their 5 or more senses. People have differing motor control abilities. What are some groups of people that have better control of their muscles than others? So athletes. Okay. Other examples of demographics. So younger people, very young people obviously have not yet figured out how to operate the most important machine they'll ever have, which is their own body. Artists, dancers, yeah, okay. Monks, that's an interesting example. Okay, let's think about differences in motor control for a moment. You are obviously creating an ASL educational game, which is going to require someone to hold their hand over the device. As you've probably figured out already, the leap motion device is not perfect. It doesn't always infer the exact orientation of the bones in your hand. You often need to hold your hand very still. in order to get this to work. So which demographics might be unintentionally disenfranchised by your ASL technology? Even if your system is very intuitive and obvious about how it's to be used, so your ASL system has very high usability, but it is not acceptable or not usable by certain groups of people. Who might be disadvantaged by your technology? People with Parkinson's, yeah, and as mentioned by Sarah, younger people, older people. So there's certain groups that are already, by definition, going to have a harder time using your ASL educational game than others. Keep that in the back of your mind as you work on your ASL educational game, and how, when you have freedom in the last 4 weeks of the semester to alter your code, how might you create it so that it's more supportive of, as Luke mentioned, senior citizens, people with arthritis, people that are missing a limb. This is going to be important as well. Okay. Obviously, people differ in terms of body shape, sizes, and colors. We will come back to that on Thursday. We will wrap up here for today. Just a reminder, you have a quiz due tonight at 11:59 p.m. I will put the quiz up by around noon today, and you can get started on Deliverable 2. I wish you a good rest of your day, and I'll see you all back here Thursday morning. Thanks very much, everybody. Bye-bye.